For this segment, we'll be going over Chapter 4 practice strips in the ECG Made Easy book titled Atrial Rhythms. I'm not going to go over all the rhythms for time reasons, but we will try to go over a few examples of each different rhythm. So the first strip in the back of the chapter for the practice strips is figure 4.25. So first thing we want to look at, is it regular or irregular? And this rhythm is slightly irregular, so we can use our scrap paper to march out, and we can see that this one does not line up. And then again, this one does not line up. So that is why I put irregular for this strip. For rate, we're just going to be using the 6-second technique because we did practice the counting blocks technique in the last few chapters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 10 gives me a rate of 120 beats per minute. Next thing I want to look at is my P waves. I do have a P wave for every QRS complex. They are all upright. Most of them are uniform. I do have one that looks slightly different here, and if you notice that this beat comes early, and then same with this beat right here, our P wave is kind of different looking, and this beat also comes early. So my conduction ratio is 1:1. I measured out my PR interval. Did measure it within normal range at 0.16, which is equal to 4 small blocks. My QRS duration I have is 2 blocks. So just try to find a QRS that lines up on a line and draw down where they meet. And you can see I have 2 blocks here, so it is narrow. And then remember here for practice purposes, we're going to be looking at our ST segment to see if it's elevated or depressed. And in this rhythm right here, it's completely normal. So my rhythm is sinus tachycardia at 120 beats per minute. That is my underlying rhythm. I do have 2 premature arterial contractions, PACs, and those are those beats that come early. So I'll circle them right here. And you can see when I was measuring out my regularity, that beat came before it was supposed to. And then this beat also came before it was supposed to. They're premature arterial contractions because they do have P waves. They do look a little different because it's coming from somewhere else in the atria. And the reason this happens is just because we get an excited cell in the atria that decides to depolarize before it's needed to. All right, taking a look at the next page, we're going to look at number 42 or figure 4.26 all the way up here at the top. First thing we're going to look for is regularity. So I can definitely tell that this rhythm is irregular. For my rate, we're just going to use the 6-second technique. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 gives me 100 beats per minute. Looking for my P waves, I can't really see any P waves. So we do have those fib waves, and I'll highlight some here. You can see how they just kind of look like squiggly lines, like this. And that is because the atria is fibrillating. We're having small impulses coming from all over the atria that's creating those fib waves. So we can't really measure our P waves or our PR interval. My QRS is narrow, and my ST segment is depressed. So remember in the previous lectures, we took a piece of paper, we put it along the isoelectric line, which is easier to do with these fib waves because they're right on the isoelectric line. And you can see from my QRS to my T wave, I have all this area that falls below the isoelectric line. And so we do call that depression. Remember, it has to be at least 2 small boxes below to be considered depression, or 2 small boxes above to be considered elevation. So for this rhythm, I put controlled AFib at 100 beats per minute. We technically don't call it uncontrolled unless it is over 100 beats per minute, but I did write this uncontrolled here just because it's right on the borderline. So if you were to call it uncontrolled, we wouldn't necessarily call it against you. But uncontrolled should technically be over 100 beats per minute. Looking at figure 4.27 or number 43, right off the bat I want to look at, is this regular or irregular? If it was irregular, I would have to consider atrial fibrillation for this rhythm, but this rhythm is pretty regular. Next, I'm going to look at my rate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Times 10 gives me a rate of 230 beats per minute. Because this rhythm is over 150 beats per minute, we're not going to be counting any P waves, which means we're not going to be counting any PR interval. For this class, we do consider any narrow complex rate that is regular and over 150 beats per minute to be supraventricular tachycardia, or SVT. So things we want to look for: is it regular? Do I have narrow QRS complexes, which I do in this one? I believe it's 1 to 2 blocks. It's right kind of in the middle. So if it's regular and narrow and over 150 beats per minute, we're going to call it supraventricular tachycardia at 230 beats per minute. And this does also have some ST segment elevation, although it's very not as obvious as the last one. So just take your piece of paper, lay it over the isoelectric line, and we can see from the end of our QRS complex to our T wave, we do have some depression that falls below the isoelectric line, and it is about 2.5 blocks. So we do want to make sure we note that. Moving on to the next rhythm, this is number 44 or figure 4.28. This rhythm is a bit trickier. So looking right at it, we can tell that it's irregular. Right here, looks like there's something missing. My rate, 1, 2, 3, 4, 5, 6 times 10 gives me 60 beats per minute. My P waves, I do have P waves for every QRS complex. They are upright, they are uniform, and remember your conduction ratio 1 to 1. For my PR interval, I measured this P wave because it seemed to start right on a line and end right on a line, and I got 5 blocks across. Remember, each small block is 0.04 seconds, so I take 0.04 times 5, which is where I got the 0.2 seconds from. For the QRS complex, I measured this complex over here because it began right at this block and ended right over here. And it was 3 blocks across, so it's right on the edge of being normal, almost wide. So for my QRS duration, I have 0.12, which remember still falls within normal of that 0.04 to 0.12. My ST segment in this rhythm is normal. So I have my QRS, my J point is up here where the segment goes into the T wave. So J point's right here where the QRS complex ends, goes right into the T wave, so it remains right on the isoelectric line. Now, what makes this rhythm difficult is right here, it's very hard to see, but we actually have a P wave that we do not have a QRS that follows. So here's my QRS, my T wave, and then you can see that it looks notched here. That is because there is a P wave there, and what that is a non-conducted PAC. So we did have the atria fire off prematurely, but that signal did not go over to the ventricles, probably because the ventricles were not finished repolarizing, so they just weren't able to depolarize yet. So the name of this rhythm would be a sinus rhythm because everything else about it is sinus. It's regular, has P waves for a QRS complex. Everything follows within normal limits with a non-conducted PAC. A lot of people miss that little P wave, and that's okay because it is really hard to see. And I have a lot of students write sinus rhythm at 60 beats per minute with a dropped beat. And if you do measure it out, it would almost perfectly be a dropped beat. So very close. All right, moving on to page 127. We're going to look at number 45 for figure 4.29. We want to look at, is it regular or irregular? It's irregular, mostly because of this beat right here. My rate, 1, 2, 3, 4, 5, 6, 7, 8 times 10 gives me that 80 beats per minute. Looking at my P waves, I do have a P wave for every QRS complex. They are all upright. So I have 1-to-1 conduction, they're upright, and I do have one that looks different. So for the most part, they are uniform, but my one right here does look a little different. My PR interval measured within normal limits, you can see I measured it right here. My QRS duration also within normal limits, I measured this complex here. And my ST segment is normal. So I have my QRS, here's my J point, falls right maybe just below or on the isoelectric line. So what this beat is here, it's a beat that came early. So you can see we're ticking along very regular. All of a sudden I just get this one beat that just decides to come in early, and it's coming from somewhere different than the other beats because that P wave does look a little different. So that is a premature arterial contraction, so it's our PAC, because it has a P wave and because it comes early. Going down here to number 47, or figure 4.31, right off the rip we can see that it is irregular. Anytime I have a narrow complex rhythm that looks irregular, I'm automatically already thinking AFib because it is a very common arrhythmia. So it is irregular. My rate is 80 beats per minute. 1, 2, 3, 4, 5, 6, 7, 8 times 10 gives me 80 beats per minute. And then I have those fib waves. So you can see here, just looks like little squigglies, and those are the fibrillation waves. So I cannot count a PR interval. My QRS is narrow, and my ST segment is normal. I do have maybe one block of depression, but we're not going to count just one block here. So you can see when I go across my isoelectric line, here's my J point. It does fall one block below the isoelectric line. So because this rate is 100 or lower, we consider it controlled. So controlled atrial fibrillation at 80 beats per minute. All right, moving on to the next page. We have figure 4.32, or number 48. This is two rhythms moving in and out of each other. So we do have what looks to be a sinus rhythm. We have a P wave for every QRS complex. The PR interval looks normal, the QRS complex looks narrow. It looks very regular to start off. And then we have an area from here to here where the rate speeds up. So I needed to count the rate for each separate rhythm. For this one, I got 16 blocks across, which gave me a rate of 94. And then for this section, I got 7 blocks across, which gave me a rate of 214. Because it is a narrow, complex rhythm, and it is regular for that section of rhythm, we're going to consider that supraventricular tachycardia because it is narrow, regular, and over 150 beats per minute. So for my interpretation, I wrote sinus rhythm at 94 beats per minute with a run of SVT at 214 beats per minute. All right, moving on, I did cross out number 49 or 4.33, but I do just want to briefly talk about it. And you can tell here that at this lower, this MCL1, this is actually a lot easier to read than lead 2. So I want to look at this bottom portion of the rhythm, just because it's a little interesting. So this last portion, if we're just looking at this section, I have my fibrillation waves. So you can see we can't really define any certain P wave out of there, so that would be a fib. But right in the middle, I do have an A flutter. So these are my flutter waves. And then here's my QRS complex. My rate, 1, 2, 3, 4, 5, 6, 7, 8, 80, so it is controlled. So I put controlled A flutter at 80 beats per minute with a variable conduction ratio. And I just picked a controlled A flutter because for the most part, the majority of the rhythm, it is a flutter. The reason it has a variable conduction ratio is we always want to remember we want to put the number of P waves to QRS complexes. But this one changes a little bit. So here I have 1, 2, 3, 4. 1, 2, 3, 4 here. Over here I have 1, 2, 3, 4, 5. And then back to 4. 1, 2, 3, 4. 1, 2, 3, 4 again. So it does change. It doesn't remain consistent. Therefore giving it that irregular rhythm to it. So just make sure for your flutters you are putting a conduction ratio. Looking at number 50 or figure 4.34, the last one on this page, it is irregular. So we can tell here that it just varies a little bit. Looks like it slows down here at the end. For my rate, 1, 2, 3, 4, 5, 6, 7 times 10 gave me 70 beats per minute. I have no defined P waves, so those are the fibrillation waves. Therefore, I cannot count a PR interval. My QRS duration is a little bit on the wider side, but it is considered within normal limit at 0.12 seconds. And my ST segment is normal. So here's my J point where my QRS complex ends, and it looks to be right on that isoelectric line. So for this rhythm, we're going to call it controlled atrial fibrillation, or controlled AFib, at 70 beats per minute. All right, going on to number 51, or figure 4.35. This one is a little more difficult to read. First off, it does look regular. So we're going to put regular for our rhythm. Our rate, 1, 2, 3, 4, 5, 6, 7 times 10 gave me 70 beats per minute. And then look at the P waves. So this wave, it's kind of joined right with that QRS complex, this P wave. And that's actually something called a delta wave. Delta waves are seen in a condition called Wolff-Parkinson's White syndrome. You can see how it kind of goes right into that QRS complex. And then we have our P wave coming out a little bit more. We have a notched P wave here, another notched P wave, and then you can see it's going right back more towards that QRS complex. So what that means is my pacemaker site is not necessarily staying at that SA node, it's moving around. And what happens with Wolff-Parkinson's White syndrome, if this is my heart, okay, there's my 4 chambers of my heart. This is my SA node, my AV node. There's some kind of accessory pathway. It doesn't go straight from node to node. It kind of travels along a different route, and we call those accessory pathways. But because all the P waves look different, we're going to call it a wandering atrial pacemaker. And that's just because the pacemaker site for this rhythm is just moving around. So I have it hitting here close to the SA node, then maybe a little more towards the AV node, maybe get a little closer, and then it's going to go back up and back up here. So we call that a wandering atrial pacemaker. For number 52, or figure 4.36, we want to see if it's regular or irregular. So I'm going to take my piece of paper here. And we started off pretty good, and then right away we got one beat, might be early. Looks to be regular here. So we do have a couple beats that do not match up, so I put irregular. For my rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 times 10 is 120 beats per minute. For my P waves, I do have a P wave for every QRS complex. Here, this notched wave is a T wave and a P wave very close together. So most of them are uniform, but there are two that are different. But I do have a 1-to-1 conduction ratio. My period interval measured normal at 4 blocks, so 0.16. My QRS duration was narrow, and my ST segment is normal. So here's my J point. I'm at the end of my QRS complex. It's right on the isoelectric line and goes right into the T wave. Interpretation for this rhythm is sinus tachycardia because it is over 100 beats per minute with 2 premature arterial contractions. And I've marked little arrows down here that'll show you those 2 beats that came early. They did not line up when I was going through checking to make sure that things were regular. Figure 4.38. We can see right away that this rhythm is very, very fast, so I'm already thinking SVT, but I need to make sure it hits all the conditions. It is regular. The rhythm is very regular. My rate is over 150. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Times 10 gives me that 220 beats per minute. And my QRS is narrow, so it hits all 3 of those things. It's regular, has a narrow QRS, and the rate is over 150, so it is going to be supraventricular tachycardia at 220 beats per minute. And we do have some pretty moderate ST segment depression here, so I'm going to line my paper along the isoelectric line. So look where you can't really see P waves on here, so you want to look at where the QRS complex starts, because the QRS complex will always start from the isoelectric line. And you can see all this area below here. I have 3 to 4 blocks here of depression. So that's what gave me the interpretation of SVT with ST segment depression at 220 beats per minute. Going down here to the third one, number 56, or figure 4.40. I see these sawtooth waves here, which is already giving me an indication this is probably going to be a flutter. But we're going to go through. It is regular. An A flutter can be regular or irregular. It just varies on if it has a variable conduction ratio or not, or a consistent one. My rate, 1, 2, 3, 4, 5, 6, 7, 8, so it's 80 beats per minute. For my P waves, I have 3 to 1. There's actually 4 to 1 here. And if you don't pick up on it, it's okay. But down in this ST segment, you can see the notch there. That's actually a P wave that's buried in that ST segment. Because remember with atrial flutter, our atria are just firing along probably 200 to 300 beats per minute. So it doesn't really stop just because the ventricles are firing off. So I actually have a 4 to 1 conduction ratio here. I cannot count a PR interval because I do have constant P waves going on. My QRS is only 2 blocks, so you can see here. I measure out my QRS, it measures to be 2 blocks. And I definitely have some ST segment depression here. So remember, we can't always go by the P waves. We want to line up our paper where the QRS begins, and that'll give us our isoelectric line. Here's my J point where the QRS ends. You can see it ends with 3 blocks below the isoelectric line. So that gives me that ST depression. So I've controlled A flutter, at 80 beats per minute with ST depression. We still use the controlled versus uncontrolled for A flutter. So if it was over 100 beats per minute, it would be uncontrolled A flutter. And then for this one, we also have to put a conduction ratio. So I'm going to put 4:1 here since we found that hidden P wave in that ST segment. So the full name would be controlled atrial flutter at 80 beats per minute with ST segment depression and a 4:1 conduction ratio. All right, moving on to number 57, or figure 4.41. We can see that this rhythm is irregular, very irregular, and it's narrow, so I'm already starting to think AFib. My rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 gave me 100 beats per minute. I don't have any defined P waves. If you can't see P waves right off the bat, they're not there, so don't try to turn fib waves into P waves, but you can definitely see here that there are no defined P waves in that highlighted area. So because I have fib waves, I cannot count my PR interval. My QRS is narrow, and my ST segment is slightly depressed. So since I can't line them up on my P waves where they begin, I'm going to line them up where my QRSs begin. There's my isoelectric line, and you can see that my J point, so here's my QRS, where the QRS ends. It ends below that isoelectric line, quite a few blocks, so we're going to go ahead and call that ST depression. So my full name is controlled atrial fibrillation at 100 beats per minute with ST segment depression. I want to skip down here to number 59. Regular, irregular. You can see that it seems to get slower in the middle and then speed up on the side, so it's irregular. It's narrow complex, so I want to be thinking AFib. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 give me 90 beats per minute. And what cancels out AFib is that I do see definite P waves. So no fib waves here. And I do have one P wave for every QRS complex. My PR interval is normal, my QRS duration is narrow, and my ST segment is normal. My QRS complex ends here, right on that isoelectric line. So my interpretation is going to be a sinus arrhythmia at 90 beats per minute, not AFib, because I do have those defined P waves. All right, looking at number 60, or figure 4.44, regular or irregular. My rate is irregular. My rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 gives me that 110 beats per minute. And I don't have any defined P waves here, so lots of squiggly fib waves. A little more coarse than some of our other examples. My ST segment is normal, my QRS is narrow, and I can't get a PR interval because I don't have any defined P waves. So because it's irregular, it's narrow, and I have those fib waves, we're going to go with atrial fibrillation. It is uncontrolled because my rate is over 100, so uncontrolled AFib at 110 beats per minute. Skipping down to number 62, or figure 4.46, regular or irregular. This rhythm is regular. My rate, 1, 2, 3, 4, 5, 6 times 10 gives me 60 beats per minute. For P waves, yes, I do have P waves. They are all upright and they all look pretty much the same, so my 1:1 conduction ratio. My PR interval I measured out here. I got 5 little boxes, which gave me that 0.2 seconds. My QRS duration, figure out where it starts and where it stops. I got 2 boxes across, which is what gave me that 0.08. And my ST segment's normal, so here's where my QRS ends, and it ends right on that isoelectric line. So this is a normal sinus rhythm at 60 beats per minute. Looking at number 64 now, or figure 4.48. Regular or irregular. So it's definitely irregular. I have a huge space here, a little shorter space here. My rate, 1, 2, 3, 4, 5, 6 times 10 gives me that 60 beats per minute. I have no defined P waves, so it's fib waves. For that reason, I can't measure a pure interval. My QRS complex, it's very small. That's still a QRS complex. It just means it's a lower voltage, but it is narrow and within normal limits. And my ST segment is normal. So you can see where the QRS complex ends. It's kind of right on that line, maybe one box below. So this interpretation would be controlled AFib at 60 beats per minute. Going down to number 65, or figure 4.49, regular or irregular, marches out to be very regular. My rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 10 gives me that 110 beats per minute. P waves, I do have a P wave for every QRS complex. This is my T wave, and my P wave, my P wave's there. They all do look the same. I have one P wave for every QRS complex, and they're all upright. My pure interval I measured out to be 4 small blacks, or 0.16, which is in the normal range of 0.12 to 0.2. My QRS duration I measured out to be 2 blocks, and you can see it very well right here. So 0.08, which falls in that narrow category. And my ST segment is depressed. So looking at this complex right here, I have my QRS. It ends right here. And laying my paper across that isoelectric line, you can see we're 3 to 4 boxes below that isoelectric line. So I do have ST segment depression. And that gives me the interpretation of sinus tachycardia at 110 beats per minute with ST segment depression. So review some of our sinus mechanisms here. I just want to look at the top rhythm on this strip, or I'm sorry, on this side of the paper. So this is figure 4.5. We can see it's very fast, so I want to look for those 3 things that would make it SVT. It has to be regular, over 150 beats per minute, and narrow complex. If it was irregular, I would be thinking an atrial fibrillation with like an RVR, which means rapid ventricular response, or over 150 beats per minute. But this one is regular. My rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, which gives it 180 beats per minute. And my QRS is narrow. It's only about a block, maybe a block and a half. So it is narrow. So I have all 3 conditions that would make it SVT. Now here we do have some ST depression. So I'm going to lay my paper along the isoelectric line. So I'm going to match it up with all the QRSs where they begin. And you can see down here my J point, and that's where the QRS complex ends, is well below that isoelectric line. So here's my QRS. Oops, that's where my QRS complex ends. And then it goes up into the T wave, giving me that ST segment depression. All right, this is the last page. Let's see if I can fit all my writing on there. All right. So we're looking at this first one, number 69 up top. Regular or irregular, the rhythm does appear to be regular. My rate, 1, 2, 3, 4, 5, 6. So my rate is going to be 60 beats per minute. And now look at my P waves. So up here I do have upright uniform P waves. You can see it getting smaller here, and then that P wave becomes inverted. So again, we have a wandering atrial pacemaker, and what that means is our pacemaker site is moving throughout the atria. I'm just going to show a little drawing over here. I have my SA node, I have my AV node, and then the electrical impulse spreads throughout the ventricles. And then I have my internodal pathway. So what's happening in this rhythm is that pacemaker site is just moving down closer to the AV node, so it's wandering. It's wandering away from its normal pacemaker site. And that's what gives my P waves a different appearance. Now everything else about this rhythm is normal. We're not going to measure PR interval because my P waves are changing, so it's going to be a little different for each one. My QRS is narrow, and my ST segment is normal. You can see where my QRS ends, right on the isoelectric line. So this is a wandering atrial pacemaker at 60 beats per minute. All right, now we're going to look at figure 4.54. This one is a little difficult to read because it's just very odd looking. You can see at the top of our QRSs we have those bunny ears. We call them bunny ears. They kind of look a little different. And what that is just a little blockage and impulse down in the Purkinje fiber, in the bundle branches. So it's very far down the line in our conduction system. It doesn't really affect our patient too much, and we'll talk more about it later. But that's why it's giving it that very strange appearance. My rate is regular. For my actual beats per minute, 1, 2, 3, 4, 5, 6, 7, 8 times 10 gives me that 80 beats per minute. I do have a P wave, just because this rhythm does look a little odd, I will highlight them for you. So these are my P waves. So they all do look the same. They occur before every QRS complex, so I have a 1-to-1 ratio, and they're upright and uniform. My PR interval I measured out to be 4 blocks, so I measured this PR interval over here, might be about 4.5. So I put 0.16 seconds, which follows within that normal range. My QRS duration, it looks kind of white and bizarre, but it's actually only 3 blocks across. So it's right on the edge of being normal, but it is still within that normal range. So I put 0.12 seconds. Now my ST segment, I have a few things going on here. One, my ST segment is definitely depressed. So if I line my paper up on the beginning and ends of those P waves to get my isoelectric line, you can see my QRS ends down here, which is well below that isoelectric line. And then my T waves are also inverted. So here's my ST segment, and here is my T wave, which is upside down. And that's why it dips below like that. So we'll kind of highlight all these T waves so you can see that they're inverted. So a few different things going on in this rhythm. The name for this rhythm is still a sinus rhythm because it has everything follows with the normal measurements. It does have P waves for every QRS complex, so it's a sinus rhythm at 80 beats per minute with ST depression and inverted T waves. And the T waves are inverted because you can see it dips down like this. Or normally, it would be up like a hill. And then our last one here, we'll go over just to review our sinus mechanisms. Figure 4.55 or number 71. My rhythm here is irregular, it speeds up a little bit here at the end. My rate, 1, 2, 3, 4, 5, 6 times 10 gives me 60 beats per minute. I do have P waves for every QRS complex. My PR interval is normal. My QRS duration is narrow, and my ST segment's normal. You can see it ends perfectly right on the isoelectric line. So this is just a sinus arrhythmia at 60 beats per minute.